Find the inverse of f of x equals x squared minus 1, x greater than 0, and sketch the graph of each. Okay, so this is the key point here, right? This x greater than 0 here, that restricts the domain. So let's think about that. Why do we need to do that in the first place? Okay, well, let's take a look. Here's a graph, right? So we should be able to sketch the graph of x squared minus 1 pretty easily. Okay, so it's just a parabola, right? Shifted down 1 unit. Okay, so x squared minus 1 should look a little something like this, right? It's shifted down 1 unit, and it's our basic U shape. Okay, but when we take a look at the graph, right, we notice that, okay, it passes the vertical line test, which tells us that it's a function, right? But it does not pass the horizontal line test, which tells us that it does not have an inverse. The reason why is for each x value, right, or not for each, but there are some spots that have the same y value here, right? Okay, so this does not pass the horizontal line test. Right? But this is the key, right? Take a look at this, x greater than 0. What does that mean? It means that, okay, I'm only going to take the part of the graph where x is strictly greater than 0. Okay, so what does that mean? It means then that we're only going to take, for example, this part of the graph. Right? So these are all the parts of the function where x is positive. We're essentially saying that we're only going to use this part of the graph, right? Which of course means we're only using this part of the function. Okay? So we're not going to include any negative values of x in this function. Right? And take a look. Right? This passes the horizontal line test now, right? There is only one single unique y value for the whole graph, or for the whole function. Okay, so then the idea is, well, wait a minute, if it passes the vertical line test and now it passes the horizontal line test, then this part must have an inverse. Okay, so now we should be able to do the steps to find the actual equation for the inverse, right? So we'll replace f of x with y, so y equals x squared minus 1. Okay, the second step says let's replace y with x and replace x with y. And then the third step says, let's solve for y, right? Let's get the y by itself. So I'm going to add 1 to both sides. So we get x plus 1 equals y squared. And then finally, the last step here would be just to take the square root of both sides, right? Because I want to solve for y here. So some of you may like the y being on the left, so let's just switch the sides around. And then y is going to equal, now here's the key, is plus or minus square root of x plus 1. Okay? But we can't have both. Okay, we have to pick, are we going to be the positive square root or the negative square root? Okay, so actually at this point, the domain and range is going to help us here, right? So for f of x, what is the domain? Just look at the graph, right? The domain is 0 to infinity. Okay, these are all the x values, right? From 0 to infinity. What is the range? Right, the range is going to be negative 1 to infinity, right? The y values of this guy. So think about this very carefully. For the inverse, these must be switched, right? For the inverse, the domain must be negative 1 to infinity, and the range must be 0 to infinity. So that means then that we're going to take the positive values here, okay? So we're only going to take the positive values of the square root function. Now think about this as well, right? Okay, I actually should know what the radical x graph should look like, right? It's a little bit curved going this way. Okay. But this plus 1 tells me, hey, I need to shift this to the left 1 unit. So our graph of the inverse function, right, should look a little something like this. What is the importance of this? Right? Remember, every x and y value, okay, or ordered pair should be switched, right? So for example, what I mean by that is, we know that this is the point 1 comma 0, right? So then on the inverse, right, switch these guys around, the point 0, 1 should also be on the graph of the inverse, right? Once again, this is going to be the point here 2 comma 4, right? 2 comma 3, I'm sorry, it should be 2 comma 3. Which means then, right, that the point 3 comma 2 should be on the graph of the inverse, okay, as it is, right? And you can verify that by plugging in the points. Okay, so that's the relationship between the graphs of a function and its inverse. Okay, if you take the graph of the function, then the inverse should have every ordered pair x and y value switched around, right? Think about it. That's what we did, right? We switched the x and the y values.